Lesson 7. We are now experts in the vertex form, and we did a summary yesterday. And we know what all of these A, H, and K stand for and how it would change the shape of a graph. So the first question, I've got this out of your textbook, is the parabola moves 4 units to the right. So we start with y equals x squared, the parabola that we're very familiar with, the one that has the vertex at the origin. And the question states it is 4 units to the right. So when I read that, I know that that is a horizontal change. That means it's going to be in with x or in the brackets. So if I'm going to the right 4, I know it's going to be either x plus 4 or x subtract 4. Horizontals are always that backwards thinking, so it would be x subtract 4 squared. Part B says a parabola moves 5 units up. So from the normal parabola y equals x squared, if I am moving it 5 units up, that's a vertical change. So I don't need to do anything in the brackets. I have my x squared, and I have a translation up 5, positive 5, as you would expect. The parabola moves 2 units to the left. Horizontal change, that's in with x or within the brackets. If I am going left, it's plus 2. B, the parabola moves 3 units down. I know that's a vertical change. I don't need to have anything in the brackets with the x. 3 units down would just be outside. The parabola is congruent to f at x equals x squared, but opens down. Congruent to means same shape. But if it opens down, I need to flip it across the x-axis, so it will be upside down. That's a vertical change, so that negative is outside in front. And I don't have any larger value for a than 1 because it's the same shape. The parabola is narrower and opens upward. The y-coordinates have been multiplied by a factor of 2. So it opens upwards. I don't need a negative. It says it's narrower, and the y-coordinates have been multiplied by a factor of 2. This is a skinny parabola. And I need a 2 because that's a vertical change. If I'm making it skinnier, I'm pulling it upwards. I need a 2 in front of my x squared. The parabola is wider and opens downward. So I know 2 things. If my parabola is wider, my a value is a fraction. If it opens downward, I know my a value is negative. The y-coordinates have been multiplied by a factor of 1/2. Aha, I knew it. A is a fraction. So I have y equals, upside down means negative, and it's told me that it's exactly half the step pattern, which will give me a wider parabola, and I need my x squared to give me a quadratic. Today our focus is going to be on graphing a couple of these. So if you want to hit pause and grab a piece of graph paper, or if you have one in front of you, it's easiest if you are able to graph these as I do with different colors. It can be really helpful. So the first thing I'm going to do, if I've been asked to graph a parabola using transformations, basically that's saying show all your work. The first parabola that I'm always going to draw is my basic parent function parabola, y equals x squared. And I know y equals x squared, and I'm going to draw a quick table of values and then never do it again. I have squared my x values to get my y values. So -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. I know my step pattern starts at 0, 0, over 1, up 1 in both directions, from the vertex over 2, up 4, in both directions, and so on, I have my basic parabola. Working left to right, I'm going to do my transformation. The first transformation that I see is the 3. So the next parabola that I'm going to do is y equals 3x squared. Let me just sneak there. Y equals x squared is the first one that I did. The second one that I'm going to do is a parabola y equals 3x squared, which is 3 times as skinny, or a vertical stretch factor 3. I'm going to take my original parabola, which has not been moved left or right, up or down yet, so it has the vertex 0, 0. And instead of over 1, up 1 for the next points, I go over 1, up 3, both to the right and to the left. Instead of over 2, up 4, I'm going to go over 2, up 12. About there in both directions. I cannot squeeze any more than that, but you should see a parabola that has been stretched 3 times the step pattern. The next one that I'm going to do, because I'm working left to right, is including the 2 in the brackets, which is a horizontal change, and it is to the right 2. So I am taking my blue parabola and I'm moving everything to the right 2. Starting with my vertex, it's now 2 to the right. And I know my step pattern is over 1, up 3, both to the right and to the left, over 2, up 12. And I have a quick parabola that should look congruent or the same shape, 2 to the right. The last transformation is the plus 1, and that is a vertical transformation where I take my whole parabola and move it up 1. So I take the green one, everything gets moved up 1, and I'm only thinking about my key points and drawing my parabola, which should be congruent to the blue one and the green one. There, very more or less on a smartboard, is my final answer for y equals 3x minus 2 squared plus 1. Y equals negative 2x minus 3 squared plus 1. I am starting with my parent function, y equals x squared. 0, 0. Over 1, up 1, back to the vertex. Over 2, up 4. 2, 2, 3, 4. Over 3, up 9, and so on. I'm working on squared x values for my y values. A little lumpy on the right. Sorry about that. Second one, I'm working left to right. I'm going to put both the negative and the 2 into my next step. The negative means upside down, and the 2 is a vertical stretch factor 2. It's going to be skinnier. Okay, so I have the same vertex. I haven't moved left or right, up or down, but all my steps are going to be upside down now. Instead of over 1, up 1, it's going to be over 1, down 2, both sides. Back to the vertex. Instead of over 2, up 4, it's going to be over 2, down 8. Sorry. 8 on both sides. And there we have an upside down, twice stretch. There. My third 1 is going to include the 3, which is a horizontal change. It is 3 to the right. You don't have to write the little English blurb beside, but it can sure help to keep things straight. So I'm taking my blue one and everything is being moved to the right. So there's my new vertex. These 2 points are each moved 3 to the right. Or I can just count my step pattern. So on. Last one is with the +1 on the end, where I take the green parabola and move it up 1. It's a vertical translation, up 1. Here we go. You can see why colors can be very helpful. I have pencil crayons if you need them. Just ask for them. There is my final product in red. Last one. Y equals -1/2 x plus 1 squared minus 5. Starting with our parent function, y equals x squared, 0, 0, over 1 up 1, over 2 up 4, over 3 up 9, over 4 up 16. There we go, y equals x squared. The second one, I'm going to do both the negative and the 1/2. So the negative is upside down. The 1/2 is going to make it wider. Upside down. It is a vertical compression factor 1/2. All of that to say, all my step patterns are going to be halved. So, vertex hasn't changed. I am going to go upside down. Instead of over 1 down 1, I'm going to go over 1 down 1/2. All the steps have been halved. Instead of over 2 down 4, it's going to be over 2 down 2. Instead of over 3 down 9, it's going to be over 3 down 4.5. There is our basic shape, and it should look wider and upside down. Third one, we are going to put the 1 which is 1 to the left. Everything to the left. 1. I hope you have better luck with your paper. Okay, last, we're going to move the entire thing down 5 because we have a vertical translation, -5. Okay, 2, 3, 4, 5, over 1/2, over 1/2, over 2 down 2, and this one disappears quickly. Notice that my red parabola does not have any x-intercepts. That happens from time to time with parabolas. I have a handout 4.3.2 for you. It is in your course notes, but I have it with little graph grids printed off for you if you'd like that, or use your own graph paper. And I recommend that you use different colors.